Welcome back. Now that we have covered almost all the available data types in ClickHouse, let us now try our hands in designing a ClickHouse table based on these data types. For now, let us ignore the choice of table engine since we will cover them later. Let us assume that we have been tasked with designing a table in ClickHouse which will be used to store the data collected from a wearable smart device manufactured by a company. The device is expected to periodically send the metrics which will be stored in the ClickHouse table. The data received from the wearable device will include device ID, which is an unique ID for each and every device. It consists of alphanumeric characters, and the length of the unique ID depends on the device model. We will also receive the name and the gender of the device owner, and multiple options are allowed for the gender field, and the user may even decline to provide the information. Next is the timestamp field, and this will have the time at which these metrics are recorded. Apart from this, we will receive the heart rate, blood pressure, oxygen saturation at the given timestamp. We will also receive the total distance covered by the wearer since midnight, the total number of steps, calories burnt since midnight until the timestamp at which these metrics are recorded. Along with these, we will also receive the altitude, latitude, and longitude in the given timestamp. Finally, we will also receive information regarding whether the unit of measurements are in US, UK, or in standard international system. I will go ahead and show you the create table statement with appropriate data types for these fields. These are my choice of data types for these fields. The device ID, device model, and the owner name are stored as string because they are made of alphanumeric characters or simply alphabets, and they can vary in length. Since there are very few options that are possible in the gender column, I'm going to store the gender values with low cardinality data type on top of string data type. For timestamp, I'm going to use datetime data type because the expected precision is in seconds. For heart rate, I'm going to use the unsigned integer 16 because the heart rate can vary between 0 and possibly up to few hundreds in rare cases. Similarly, for blood pressure, I'm going to use unsigned integer 16, and blood pressure is stored in two separate columns to record the systolic and diastolic blood pressure. For oxygen saturation, the values are in percentage, and hence I'm going to use float 32 for this column. Again, I'm going to use float 32 for distance, or we can also use 32-bit unsigned integer to store the distance if we are not bothered about the fractional values. Similarly, I'm going to store the steps as 32-bit unsigned integer and the calories burnt as 16-bit unsigned integer. The latitude and longitude information will be stored in a single column called position and using point data type. I'm going to store the altitude values as 16-bit unsigned integer because the device wearer is expected to be at the sea level or sometimes in the mountains while wearing the device. And finally, I'm going to store the unit values as enumerated data type with three possible values that includes standard international or SI, US and UK system. Let me go ahead and create this table. After the table is created, let us insert some random data into this table. Here, I'm going to insert 100 rows of data with random values generated for each of these columns. After the data has been inserted, let us read the data from this table. In this example, I'm going to read 10 rows from this table. Since we have inserted random data into the table, this data may not make sense, but we have seen that this table works. So based on the requirements and the data fields, we will have to evaluate the possible data types and come up with the optimal data type to store those fields. I hope this helps, and thanks for joining.